Hey guys, so today I'm going to take you over how to do a sphereless eye rig. Before I jump into that, I wanted to say thank you to Ryan Griffin. I got a lot of my material from this video. There's a link in the description below, so go check him out. Let's get into this rig though. So this is a kind of eye that you'd see on like a Looney Tune, maybe Daffy Duck or something, and with this rig it allows you to slide the pupil along the sclera, and it pretty much just stays constrained there. So you can get your full range of eye motion here. And I've incorporated a scaling feature since Toons like to exaggerate. You can get the dilation in the pupil. Another thing you can do with this rig is really like push the form. Let's do something like this. Soft select, push it outwards, even upwards. And you'll notice that everything is still going to work for us. So you'll be able to really push your Toon Eye or whatever you're using it for pretty far before it breaks. So we're going to jump directly into getting this rig set up. So to speed this up, I already have the geometry in place. It's very important that this is a NURB surface, and the pupil can be whatever you'd like it to be. Excuse me. So what we're going to do is we're going to select the NURB surface, go to In Dynamics, in here, and we're going to open up the options. I'm going to reset, and all you really have to do is take the U and the V count down to 1. We're going to create the hairs, and you don't need the nucleus, paint effects, or the hair system. What we're really looking at is this follicle right here. So we're going to have a single joint in here. I'm just going to type in joint. I think that parented it under. Oh, cool. So the joint's already exactly where we want it to be because I had this selected when I typed in joint there. So assuming this is a 2-eye system, we're going to say LTI, call it the spine. Alright, so that's exactly where we need it to be. Going to... Alright, cool. So we should be good here. Now for the next step, we're going to want our control. So I'm just going to use NURB circle, and we can just snap this in there. So we can go child, parent, and we can just press P, and we can zero these out. And then we can unparent it, shift P. And right now, all we really need to do is affect the components. If you press function F9 for Mac users, it'll take you into CV mode, and you'll only affect these. Pull it pretty far out. I think that's a good size. Jump back into component mode, and then we can freeze the transforms. Alright, cool. Alright, perfect. And those should match up. Okay. For the U and V. Okay. So for this, let's just name this to keep it consistent. Icon. Alright, so in Ryan Griffin's video, he shows you guys how to set something similar up to this, and he uses a script. I'm going to show you how to do it using nodes. So the nodes we need are the icon and the follicle, and we're just going to add those in. We don't need the shape node of the icon. Make sure you're using the garbage can icon to delete these from the node editor. If you don't, you'll actually delete them from the scene. And we do need the shape node of this, but we don't need that one. Okay, so what we're going to do is we're going to use plus minus average nodes to connect up the translate, or to sync up the offset between the zeroed out translate values and the 0.5 on the parameter U and V values of our follicle. So first things first, let's do the plus minus average. Before we name this, I like to just check. So under our follicle, U should be translate Y, and it is. You can see it driving our joint. So U is going to be translate Y. So what we're going to do is going to say translate Y underscore U parameter, and then we're going to say plus minus average. And then we're just going to duplicate this because we're going to need another one for the translate X. And translate X is going to, by default, affect the V. and the operation in these should be set to sum by default, so we're fine. And we're going to need the values of the u and v parameter on this. So we're going to take the parameter u, and we're going to put into input 1D, and then we're going to take this, we're going to say translate y for that. Translate y is going to go as a second input. Now we don't want this connection to stay, we just wanted that value. And the reason I did that is because I don't see a place to put those in, so we're just going to connect them up and then just delete the parameter we don't need. So v is once again going to go here, and then this one looks like x for us, and then we don't need that one. Alright, so with this setup now, we can take the the output, and we're going to put it into the u. And you can tell which one by the way we named our plus minus average nodes. And this one's by default going to go into v. If we did this right, there should be no offset or anything. Everything should be in place. Awesome. So our joint's moving the way we want it to. All we have to do is get the pupil to be bound to the joint. And your bind options really shouldn't matter. It's going to be a 100% weight. Let's see if I can get away with this. Should be able to hide that. Yep, we can hide it. And now our thing is moving the way we want. Now in the video I showed you, we didn't have such a dramatic transform. I compensated for that with plus minus average nodes. Or sorry, multiply divide nodes. We don't need these. Okay, so what we're going to do is going to say multiply divide. We're just going to take this. We're going to call this mult. And we want this set to divide, and we're going to put a number like 6. I know that 6 gives us a good result, but I literally just played around with that. So we're going to duplicate that. Cool. We're going to take this, copy, paste, and this is going to be mult. And all we really have to do is just pipe in the math here before it hits the plus minus average, and then everything should still work for us. So let's just take this out, and we know this is translate y. I'm going to put it in to the input 1x, and then we're going to say output x is going to go into the 1D. So taking a look, it's going to be 0 over the 6, and then this is still going to line up to what we need it to be. Translate x, input 1x, output x. Yep, and yes. And now, when we come over here, awesome, we are getting exactly what we want it to do. And then, as a little bonus, I just went over here and it said scan constraint, there we go. And I just put a simple scale constraint on the joint. And now that we can move it, we can also do the scaling. And because the follicle does a lot of that work for us, we can do some really crazy crap. And our eye system still works. So I hope that was helpful. I hope you guys find other uses for this. Here's the node network. One last time, don't worry about this. And you guys can even bookmark this. Alright, so I hope that was helpful. Once again, thank you for watching, and feel free to hit the subscribe button. And also, once again, a lot of thanks to Ryan Griffin. You guys take it easy.